the distance between two points A and B on a transverse wave is 5.0 meters. And this is the wave. Okay, let me draw the wave here. So A is here, point A is here, and then point B is here. We are told that the distance between point A and B this is equal to 5 meter, 5.0 meter. The wavelength of this wave is, so the question is that what is the wavelength of the wave? So the question demands the wavelength of the wave. And then the third question is also a graph. This wave has an amplitude of 0.01, rather 0.01 minus, and then 0.01 meter positive. This is 0.00. It's a graph of displacement y against time. This is this point is 0.05, and the other point is 0.10 seconds. So the horizontal axis is time. So what is the frequency of the wave? What is the frequency? What is the frequency of the wave? So these are the three main questions for our consideration. The first question is this graph. We have this wave, transverse wave. A section of it is labeled as 3.0 meter. This is 3.0 meter. So the periodic wave in the diagram has a frequency of 40 hertz. We are told that the frequency of this wave is 40 hertz. So if the frequency is 40, what is the speed of the wave? Then the second question In the diagram below, which is this, the distance between 2 points A and B on the transverse wave is the distance between 2 point A and B on the transverse wave is 5.0 meter. So the distance between A and B on the wave is 5. What is the wavelength of this of the wave? And then the last question is that it's also another graph. Okay, it's a graph of displacement against time. And the question seeks what that determine the frequency of the wave. So I'll quickly give it a try, and then let's continue our discussion from there. If you are done with question 1, let me share with me whatever you had. If anybody is through with question 1. Those of you who joined earlier, you must finish question 1 by now. Charlotte, Jeriel, and Co. Equia Watma got 120 meter per second. We shall see. Equia, we shall see. Yes, who else? Equia is true. Who else is done with question 1? Charlotte, you were here earlier.
Yeah, but
You are thinking through. Jeriel, what have you had for question 1?
Hello, please, you said.
What have you had for question 1? Oh, you are still on it.
Yes, I'm still on it.
Okay. Othniel, what did you get for question 1?
Yeah, please, I had the same thing.
120.
Yes, please.
Open your eyes, oh. Equia Watma, open your eyes.
Mr. D, I've changed it. I said I go 180.
180. Equia
Yes.
Watma must still open her eyes, oh. Yeah, Festus.
Please, is it 240?
Festus is asking a question, oh. He's not giving me an answer.
I'm not really sure if that's right.
Okay. All right.
Mr. D, 3 times 4, 240.
Pardon? Okay, I understand why. Okay, I get you. I get you. I want to make another changes. Fine, this one holds. But what if the dimension in question is this? It's from this point to this point, and we are told it's still 3.0 meter. So if it is this, what will you have as the speed of the wave? Earlier, we considered from this point to this point. Okay, now it's like a B of it from here to here. What will be the speed of the wave? If it's like this.
is it 60?
Hey, you are also asking
180.
You are also asking a question on. Yes, Festus.
120 meter per second.
I think the first one will be, yes, 120 as you had, as some of you had. And then this time, this will be 60. Let's go through for the sake of time so that you answer the 2 and 3. So we are looking for the speed. Speed is F lambda. F we are told is 40. Lambda is what we are looking for. So if the question is like this, if there's a dimension in question, then this is trough and this is another trough. So the wavelength is the distance between successive troughs or successive crests. Okay, so it means that what we are given here is the wavelength. So 40 times 3 meter, and that will be 120 meter per second as some of you had. Now, if it is this, if the dimension in question is this, then this is 3. Okay, the indicated point dimension has a whole length of 3, but we are looking for wavelength. So we have 2 complete waves within this. So if we have 2 complete waves, it is like lambda. We have 2 lambda equal to the whole length given 3. So lambda in this case will be 3 on 2. So if lambda is 3 on 2, if lambda is 3 on 2, then the velocity in this case will be 40 times 3 on 2. Okay, this is 2, so 60 meter per second. So that's the trick, and some of you had it. Any question? So when you are given a graph, this is how to go about it. Okay, are we through? Hello?
What are we supposed to find in the question 2?
The question 2 that in a diagram below, the distance between 2 points A and B on a transverse wave is 5. There's a question. What is the wavelength of the wave? What is the wavelength of the wave? Who is through with this? Question 2. Who is through with the wavelength? Oh, I have people here. Who is through? Please, if your hand is up, go ahead and share your answer with us. If your hand is up, go ahead and share your answer with us.
Please, is it 2?
2 Ghana cedi, Charlotte.
2 meters.
Okay, so Charlotte is getting 2 meter. Who else?
2 meters.
You also had 2. Yaba, what did you get?
I had 2 meters.
Let's see. Let's see if it's really 2. So,
I had 1.
what, Daria, what did you get?
1.6.
1.6.
Yes, sir.
Let's see. So the length of the wavelength of the point A from A to B is 5. Now, how many complete waves do we have in here? This is 1. If we are picking from this point in phase, 1, 2. So 2.5. If we are picking from crest to crest, this is 1, 2.5. 12 to 12. So we have 2.5 or 2.5 lambda being equal to 5. Therefore, lambda is equal to 5 over 2.5. And this is 2 meters. So those of you who had 2 meters, you are on point. All right, the last question. The last question. This is the wave. Let me clear this question. This is the wave. It's a graph of displacement against time. And this is going for a time of this. The question is that what is the frequency of the wave? What is the frequency of the wave? Anybody? Whoever is true. Yes, Charlotte.
Miss Dedia.
Uh-huh. Lizzie. I'm recording, sorry. Ekuya Boatma is getting 20. Ekuya, we shall see. We shall see where the power lies.
She said she had what?
20.
Okay.
Ekuya, how did you do it?
Mr. Their frequency is equal to number of cycles or waves over time.
So,
And in the diagram, there are 2 complete waves, and the time is 0.10. So it's 0.10. That
so
gives 20.
2 complete waves divided by the time for that number of waves.
Yes.
Is that what Ekuya is saying? Okay. I'll also see if truly your answer. So, Ekuya, what Ekuya Boatma is saying is that, you see, because frequency is equal to number of complete cycles divided by time, she counts the number of complete cycles. So 1, 2. So 2 divided by the time taken to make this number of cycles. which is 0.1. And so she divides to get 20 hertz. Another way out is this. F is also equal to 1 over big T, period. And period is the time taken to make one complete cycle. So what is the one complete cycle? This is a complete cycle. And the time taken to make this is 0.5. So 1 divided by 0.05. And this is 5 over 100. So 100 divided by 5 would also give us 20 hertz. So that's it. Both ways would give you the same results. So a typical application of whatever we have done. Please, any question? Any question? No question. All right. Let's continue our discussion on waves. Now, if you visit the seashore and then you see the ocean wave coming, you realize that the ocean wave, the size of the ocean wave that is coming will decide whether you are to run away for your life or still be at a standstill. Some of the ocean waves are such that when they are coming, you must run away because you fear that when it gets to you and then hits you, you can fall and then get drowned. Okay, so you deciding to run away or stay actually depends on the size, the height of the wave which is coming. Some waves are such that when they are coming, you can even go and emit it. Some of them too, nobody would advise Charlotte to run away because the size alone would scare you. This thing which informs you whether to run away or stay determines the energy carried by the wave. So the amount of energy carried by a wave is determined by its amplitude. The amplitude, if we draw a progressive wave, and a wave is like this. If I should draw another one, and it is like this, the size from the x or the time axis to wherever the crest is determines the energy carried by the wave. So by this drawing, it means that this one is more energetic than this one. Okay, and this side along the y-axis is the amplitude. This height above x or along the y-axis is the amplitude. So the energy carried by a wave is determined by its amplitude. Okay, so take notes. The energy carried by a wave is determined by its amplitude. When the amplitude is large, it means the wave carries very huge amount of energy. And that is what is scaring you to either stay or run away. All right. Now, yesterday we looked at classifications and we saw mechanical waves, and electromagnetic waves. EM for short. Mechanical waves require a medium before it can be propagated from one point to another, whereas electromagnetic waves do not require any medium. I gave you examples. Then we saw another classification, which is how particles, the manner in which particles vibrate, and how the energy is propagated within the medium. Hence, under this classification, we talked about transverse wave and longitudinal waves. Okay, and then saw that under transverse wave, the vibration of particles of the medium is perpendicular to the propagation of the wave. Okay, whereas in longitudinal wave, the vibration of particles of the medium is parallel to the propagation of the energy. Here too, we saw a lot of examples under these two classifications. There is another classification which is known as progressive wave, and stationary wave. So progressive and stationary wave. Okay. So we will look at each one of these two classifications. So today we are going to look at what a progressive wave is. A progressive wave. When we talk about a progressive wave, progress means movement. Okay, movement. So a progressive wave is any kind of wave that can be propagated continuously from one point of a medium to other points. Okay, a progressive wave is any kind of, it's a wave. This is a wave that can be propagated continuously from one region or area of a medium to another. So any a wave that can be propagated continuously from one region of a medium or one area of a medium to another is a progressive wave. In the formation of a progressive wave, the medium must be very large. So if you have very vast or large medium, whenever energy hits one part, okay, the energy will be transmitted continuously from where it starts throughout the medium. Okay, this kind of medium wave is what we are terming as a progressive wave. In fact, most waves we find around, mostly waves are progressive. Waves are mostly progressive. Okay. And the medium must be very large, implies that this medium through within which the energy is propagated must be so big, large. So long as the medium is so big, the energy will be transmitted on and on and on and on till it dies out at the shore. So an example of a progressive wave is ocean wave. You know, in ocean wave formation, the water medium is so big. So when the wind blows and then the energy of the wind flashes the surface of the water where it actually started from, the energy of the water is propagated on and on and on and on continuously till it ends at the shore. Okay, so usually the ocean wave we see when we visit the seashore is such that when it starts, it is very huge. Okay, the amplitude is very large, but as time goes on, because of the consistent, okay, transfer of the energy and then friction, water molecules hitting one another, the energy will be dying out gradually till it ends up at the seashore. So honestly, practically, waves and a wave is not drawn. Waves practically are not such that they have a constant amplitude throughout. No, we always draw a wave as if it is a kind of free oscillation. No, practically, waves are such that because of air resistance and friction among particles, as wave propagates, their amplitude will be dropping. We call such waves as damped oscillation. This is damped oscillation. But we mostly draw waves to look as if it's a free oscillated wave, free oscillation. So in a free oscillation, the amplitude of oscillation is maintained throughout. But practically, this is what happens. Please, is that okay?
Please, I have a question.
Ask your question.
Please, so you said that progressive wave occurs in a very large medium.
When the medium is so large.
Yes. So I wanted you to give me an example of like a very large medium.
Oh, I said the ocean. You see the ocean,
What?
the ocean,
Okay.
the sea. When the ocean wave starts, where ocean wave is as a result of the wind blowing around, splashing the surface of the ocean, and then the energy of the wind is picked by the water molecules, transferred on and on. Okay, so in this case, you look at the volume or the size of the sea. So that is an example of very large medium.
Yes. And another question, please.
Okay.
Please, you see, this machine that I don't know, but then like I don't know if it takes your heartbeats, but then it gives some zigzag something.
The oscilloscope.
I don't know what it's called.
What is
Is that one 2 ways?
What is used in the laboratory and hospitals? That thing you see is a wave.
Okay.
It's a wave display. Okay.
Yes, please.
All right. So let's go through a progressive wave equation. The progressive wave equation. I earlier said that most waves we see are actually progressive waves. They are waves that can be propagated continuously from one region of a medium to another. And a wave is represented as a signed function. That is why we draw waves as that zigzag thing. So this is how we represent a wave as. Now, in mathematics and physics, when you draw an equation or a graph, and you draw something like this, mathematically, what is this? Mathematically, what is this?
Gradient.
No, what have I drawn? So what have I drawn? A, B, C. C is this. Yes, Amma.
So please, I think something moving from a point and it's increasing.
No, what does
Or
the graph represent? What does the three graphs represent? That's my question.
Constant motion.
Not so wrong, but let's still brainstorm. I want different views. What does the three graphs represent? Yeah, but what does the three graphs represent?
The equation of a line.
This is a graph, okay, a straight line graph. A straight line graph. Yeah, but it's not an equation. This is a straight line, okay, graph. Right? Now, each of these graphs have its own equation. So, if I ask you to draw something which represents a linear graph, you draw any of these three. So, symbolically, this is what represents the graph of a linear motion, okay, or a straight line graph. But a straight line graph mathematically has its equation, which is different from non-straight line graphs. Okay. So what do you think will be the equation of this one, the first one, A? What will be the equation of the first one?
Y is equal to mx plus.
Y is equal to
Mx plus.
mx.
minus
Is it plus C or minus C?
Minus, sorry.
Minus C.
Minus C, because the intercept is at the negative x, negative y. So it means the graph cuts the vertical axis here. What about this one? What about B?
Y is equal to mx.
Y is equal to mx. Why mx? Because why
From the origin.
again?
It starts from the origin. Like
Or,
0.
or it cuts the vertical axis at the negative, or start from the origin. So it means the intercept C is 0. Then what about the third equation?
Y is equal to mx plus c.
Again, Equa again.
Y is equal to mx plus c.
I won't buy it. Equa,
Y is
y is equal to
Y is equal to
negative mx
negative
plus
mx.
negative mx plus c, because this is a negative slope. If you find the slope, you get a negative value. So m is negative. And then the graph also cuts the y-axis at positive. So we are drawing a graphical representation of that, as well as a mathematical, representation of that. Two, if we are talking about quadratic graph, we have to draw something like this. Okay, and y is equal to, what's the equation? Y is equal to quadratic. Hey, Asabo, turn it one people. Hurry up. Y is equal to
ax
x squared plus bx,
b x plus c.
right? Yes. Equally. You see, we are drawing something like this. And what we are saying is that this thing, this macaroni indomie-like thing we've drawn represents a wave. So graphically, this is a wave. Mathematically, what is the equation? So that this is y against x or t. Okay. So the wave must also have its mathematical relation or equation. Hence, equation of a progressive wave. A progressive wave. That's the essence of what we'll be doing. So we want to look for the equation when written can be used to represent what we are drawing as a wave. Okay. Now, a wave is a simple harmonic kind of motion. A wave is simple harmonic. So the basic equation of a wave, is equal to the equation of a simple harmonic, the displacement equation of a simple harmonic motion. So the basic equation of a wave represents the displacement function or equation of a body executing simple harmonic motion. Now, what is the displacement equation of a body executing simple harmonic motion? Yes, you've done SHM. So let's recall. What is the displacement function or equation of a body executing simple harmonic motion? Yes, if you have forgotten, there is a clear relationship between a body executing circular motion and a body executing simple harmonic motion. So this is the origin O. When a body is executing circular motion, moves from a point A to this point. This linear displacement is directly proportional to an angular displacement at the center, theta. But because theta is equal to omega t, because theta is equal to omega t, instead of theta, we'll express it as omega t. When the body is here, we can trace its displacement on the y-axis by this point. So a position here represents a position over here, which is labeled as the displacement y. Okay. Now, because when the body is here, we want to determine the vertical displacement. The vertical displacement above the center O. Okay, so the body is here, but when we look at its oscillation along y, this is positive y minus y. When it's here, we can trace it here. So if we want to determine this value of y above O, we use trigonometry. This distance is actually equal to this. So if this is y, this is also y. Let me bring it here, y. So if we want to find this displacement or this one, when we use sine of the angular displacement, which is omega t, sine omega t is equal to y over the radius, which is this. But the radius is equal to this. Okay, this distance we call as the amplitude. So the amplitude A is equal to the radius. Okay, because this distance is equal to the same as this. So R is equal to A. So because R is equal to A, we use the hypotenuse is equal to either R or A, whichever way you represent it. So making Y the subject, which is equal to A sine omega t, gives us the displacement equation of a particle Y executing simple harmonic motion starting from the origin or the mean point O. So the displacement equation of a body executing SHM, the basic equation is given by either Y is equal to A sine omega t, or if this is when the body is oscillating above the Y, vertical. If it is oscillating horizontally, you need to find X. For determining X, we have to use cosine. So when we take cos of omega t, cos omega t is equal to X over the hypotenuse, which is A or R. Therefore, X is equal to A cos omega t. This is the displacement equation of a body executing simple harmonic motion along the x-axis, whereas the y1 is the displacement equation along the y-axis. So along the y-axis, along the x-axis. So generally, if we want to write the displacement equation of a body executing SHM, it can be this or that, either cosine or sine. So because a wave motion represents simple harmonic motion, the basic equation of a wave is given by what we've just derived. So the displacement equation of a wave, the displacement equation of a wave starting from the origin, or vibrating from the origin, is giving us either y is equal to a sine omega t or x is equal to a cos omega t. Now, class, if you write the equation in this manner, it means we are looking at a particle vibrating at the origin O. We are looking at writing an equation for a particle vibrating at the origin O. Whenever you write it as this or that. Please, any question? All right. Now, if we want to write the equation for a particle vibrating ahead of the origin, this is the origin, but we are looking at a particle P here vibrating. If you note carefully, this point P seems to be ahead of O. So we are looking at a particle P vibrating ahead of the origin O. And we want to write an equation for it. Now, you see, please pay attention to this part carefully. If we are looking at a particle vibrating here, maybe a particle L vibrating at this point, a particle vibrating here forms a wavelength of lambda. This is a complete, so lambda. This lambda in terms of angle is equal to 360 or 2 pi. Please give me a minute to pick this call from school and get back to you. All right, so this point, a particle L here, has a whole length from the origin, lambda. Now, the angle between the origin and where the particle is vibrating, we call this angle as the phase difference. So phase angle. Okay. Now, the angle between O and L is equal to 2 pi radian or 360. Okay, this angle between 2 points is termed as the phase difference. The difference between point in terms of angle. Now, the phase difference between a point here, L, and then the origin is 2 pi. So the phase difference is 2 pi. Now look at this vibrating particle P. We don't know the angle between the origin and the point P. So let's call this by a symbol phi. So phi is the angle, phi is the phase difference between the origin O, between O and P. The wavelength we don't know. The wavelength between this point L and O is lambda, but the wavelength between O and P we don't know. So let's represent that by X. So please understand the letters. Okay, X because it's along the X axis. That is why it picked the same symbol as the horizontal. So because we don't know the angle between the vibrating particle P and the origin, let's say the wavelength is X. Because we don't know the phase difference, angle difference between O and P, let the angle difference or phase difference be pi. Okay. Please, any question? Any question? All right. I'm building on. Now, when energy hits from the origin, the energy hits start from this point. Okay. A particle P vibrates before, sorry, a particle at O would vibrate before particle P because the wave is moving from left to right. The energy is moving from left to right, direction of energy. So when the wave starts, a particle at point O vibrates before P. Class, are you with me? Give me feedback.
Yes, please.
So a particle, because a particle at P, at O, vibrates before particle P, if we are writing equation for a particle vibrating at O, that is what we've done. Y is equal to A sine omega t. So A sine omega t means that a vibrating particle at the origin O. Now, for equation or an equation for a vibrating particle P, its equation will be this. You see, because O vibrates before P, meaning the energy will hit a particle at P before O. So when we are writing an equation for a particle P, we subtract the phase difference or the phase angle of P from O. Please listen to the reason. We subtract the phase difference of particle P from O because the particle P, O vibrates first before P because the wave energy is moving from left to right. So O vibrates before P. So equation for particle P becomes A sine omega t, which is the phase angle at the origin, minus the phase angle of the particle P, phi. Please, is this point understood? Class, is the point understood?
Yes, please.
Likewise, if the wave is moving from right to left, if the wave is in this direction, this time around, the particle P vibrates before O. So the difference is that this will change to plus because P would vibrate before O. And we are writing the equation for P. So if it is the wave is moving from left to right, particle O vibrates before P. So P lags behind O in terms of vibration. So for that matter, the progressive equation or wave equation for particle P becomes the phase angle of O minus the phase angle of P. All right, so that's the basic thing. Let's expand this. We know that angular velocity omega is equal to 2 pi over t or 2 pi times f. So we will substitute either this or this in place of omega here. We must also get an equation for phi. And look at how we are going to derive an equation for the phase angle phi by ratio and proportion. Now, the wavelength lambda here is to a phase angle of 2 pi radian. Okay, lambda goes with a phase angle of 2 pi. What about this x? X is also to an unknown phase angle represented by pi. Okay, so we are using ratio and proportion. Lambda is to 2 pi means that lambda over 2 pi. This is also equal to x over phi. Let's make phi the subject. Festus, help me make phi the subject here. Festus. Hey. Okay. Make me help me.
Phi is equal to 2 pi x over lambda.
So this is 2 pi
X over lambda.
X over lambda. So we've had expression for omega. We've also had expression for phi. We are going to pick each one of them and substitute it into the general progressive wave equation. Please, is there any question here? Charlotte, is there any question?
Please.
Okay, so let's do the substitution.
Mr. Dia, please, I have a question.
Ask your question.
Like starting from where the x is to, like, I don't know, but it's quite confusing. How come lambda is equal to 2 pi rad and x is equal to
Okay, that's why I said ask questions. If you don't understand any part, you see, this is a full wave. A full wave, okay, is equal to an angle of 360. So it means if I draw this, it is equal to 1 complete revolution, 360. And it is either 360 degree or 2 pi radian. So instead of writing 360 here, I'm writing 2 pi radian. Are you okay?
Yes, please.
Now, this length of a wave, which is from here to here. So the full wave is equal to 1 lambda. The length of a full wave is lambda. But I don't know the length of this wave. I don't know the length of this wave, and so represented it by x. I also do not know the phase angle. If the point is a vibrating particle is here, the phase angle is 180 or pi. But if it is here, I wouldn't know what the angle this will constitute. Charlotte, is that not so?
Yes, please.
That is why I'm representing it by an unknown angle phi. So all that I'm saying is that a full wavelength, lambda is to a phase angle of 360 or 2 pi radian. Is that not so?
Yes, please.
So lambda is to 2 pi, whereas the x wavelength, which I don't know, is also equal to a phase angle of I don't know, which I'm representing by the letter phi. Are you okay?
Yes, please.
Now, all that I'm doing here is that lambda is to 2 pi means lambda over 2 pi. X is to phi means x over phi. And then trying to make phi the subject and came to this point. I hope all is well.
Yes, please.
So
Thank you.
it's not a difficult, you just need to understand what we are doing. So when we substitute this, we have y is equal to a sine omega is 2 pi f t minus pi is 2 pi over lambda x. This is the progressive wave equation of a particle vibrating, okay, ahead, away from O. So the progressive wave equation of a particle vibrating ahead of O, which is the origin. So simple. So if we are looking at a particle vibrating ahead of the origin O, this is it. Or the other side is that when you see a minus, then it means that the wave is moving from left to right. This is what I indicated earlier. The minus means that the wave is moving from left to right, or it is moving towards the positive x axis. Okay. Let me clarify that too. This is the whole wave. This is positive y minus y. This is negative x, positive x. So if you see a minus here, then the wave is moving towards the positive x axis, or the wave is from left to right. Hey, people are gone. Yaba, are you there? Hello, Yaba.
Yes, please.
Tab.
I'm here.
Who is Tab? T-A-B. T-A-B, who are you?
This is Samuela.
Oh, okay. Samuela 10 Tab. All right. So this is the basic progressive wave equation. Or I can also write this as a sine. You see, 2 pi is common. So I can factorize out 2 pi. So I have ft minus x lambda. Or if you want to compress this equation, okay, compress the equation. When you write it like this, you are expanding it. But if you want to compress the equation, it is equal to y is equal to a sine 2 pi f is omega t. Then you see this ratio, 2 pi over lambda, is known as angular wave number. So angular wave number represented by the letter K. So this is K times X, KX. So phi can also be represented as kx, but you do not forget the fact that k is equal to 2 pi over lambda. So k, which is equal to wave number is equal to 2 pi over lambda. So when you are compressing it, you can write it as a sine omega t minus kx. And this will be the compressed form of the progressive wave equation. So by the minus, don't forget that the wave is moving from left to right. If phi is 0, then it means that the wave is just starting from the origin. So you arrive at just a sine omega t, meaning phi or kx is 0. But if there is a phase difference between a particle vibrating ahead from the origin, then you see either minus or plus here. Please, if there is any question, quickly ask before I continue. All right. So let's look at other forms of progressive wave equation. Other form. Then quickly, we'll look at how it is used in solving problems. Other forms of progressive wave equation. So the basic form of progressive wave equation is y is equal to a sine omega t minus kx. We can write it in other forms. So this is one. The second form is that y is equal to a sine omega is 2 pi f. So 2 pi f t minus k is 2 pi over lambda x. Okay, we can still be a sine 2 pi out f t in minus x over lambda. So this is the second form of the progressive wave equation. We can derive a third form. The third form is this. Frequency is equal to 1 over the period. 1 over the period. So when we substitute this into the equation, when we substitute f in place of what we have here, we can also have a sine 2 pi. F is 1 on t, so t, small t over big T, minus x over lambda. This is 3, the third form of progressive wave equation. So it's just substitution that is being done. Then the next thing is that, you see, velocity, the speed of a wave is given by f lambda. We want to substitute f here. When we make f the subject, we have v over lambda. V over lambda. So when you substitute v over lambda in place of f, you have y is equal to a sine 2 pi v, we are putting it here. So v t is already there, over lambda minus x over lambda. You could see that lambda is common. Lambda is common. So we want to factorize out lambda as well. So we have y is equal to a sine 2 pi is already out. We pull lambda out. Okay. So we have vt minus x. This is the fourth form of a progressive wave equation. So in short, the progressive wave equation can be derived in different forms. We can derive this in several different forms by picking one, substituting, and all that. Please, if there is any question, ask. Let me see the individuals who are still here. A lot of you are gone. I don't know if it's network issue or what. So Akuya Charlotte is here. Akuya Adoma, Akuya Batima, Amma, Annalyn, Dennis, Alvina, Festus, Lizzie, Lois, Nana, Othniel, Samuela, Sheila, and roll call. Sheila and Yaba. Okay. Thanks for being here.
You're welcome.
All right. Now, let's look at the last part and then we solve one or two questions. If the wave is moving from right to left and we want to write an equation for a vibrating particle P, because the particle P vibrates, we'll get to the wave is moving this way, okay? Or the energy is moving this way. If it's from right to left, particle P this time vibrates before a particle at the origin O. Okay, so when you are writing the equation for particle P, because the particle P vibrates before a particle at the origin O, the difference in the equation becomes y is equal to a sine omega t plus phi. So if you see a positive between the first angle at O and then first angle of the particle P, then it means the wave is moving from right to left. So this direction, okay, which is negative, separating the two phase difference, means that it is from left to right. Or the wave is moving towards the negative x-axis, or wave moving towards the negative x-axis. Now, if it's like this, the operator in the middle will be plus. And this is wave is moving from right to left, or moving towards the positive x-axis. Ladies and gentlemen, that is the difference. Or moving towards the positive x-axis. That's just the difference. All other relations or equations as states. Let's apply this in solving a question quickly before our time dies out. Please, I'm coming. I'm giving you a question. All right, ready? A wave is represented by the equation. A wave is represented by the equation y is equal to 7 sine. I hope you can hear me out.
Yes, please.
Yeah, network is not disturbing. Y is equal to 7 sine, open a bracket, 40 pi t, 40 pi t minus 8 pi x. Let me give you the equation. Seven sine 40 pi t. Charlotte.
Mr. Dia, please can you send the question to the platform? Because
Oh,
my network is
I'm writing it on the board.
quite bad here.
I'm writing it on the board. Charlotte. Or you can see. Forty pi t minus 8 pi x. 8 pi x, where y is in meter, where y is in meter. Where y is in meter. Now, the question, find I, amplitude. I, the frequency. I, the period. IV, the wavelength. V, the speed. And VI indicates direction of wave. Indicates direction of wave. This is the question. So simple.
Mr. Dia,
Hello.
please, I don't have the question.
Pardon?
Please, I don't have the question.
Charlotte, I'm right. It's on the board, though, or you can read.
Is that a wave? Like that's the only part.
You let me take a shot and send it to the. Maybe you can read.
Oh, I can see.
Okay. Then, if you can see, then see it.
Like I want the continuation of the sentence. Like a wave has.
A wave is represented by the equation. A wave is represented by the equation. So, how do we solve such a question? You see, when you are given the problem, you compare it with the general progressive wave equation. You compare whatever is given to you with the general progressive wave equation. So, the solution is that the general progressive wave equation, if it's moving from left to right, over here, because this is a minus, it means that this wave is moving from left to right or moving towards the positive x-axis. So I write the general progressive wave equation to look like this. So y is equal to a sine omega t minus kx. Meaning if whatever is here is plus, this will also change to plus. If the wave given to me is a cosine, the general one must also be a cosine. Okay. Then you compare the equation given to you to the general progressive wave equation. So we are going to compare this with y is equal to 7 sine 40 pi t minus 8 pi x. We are going to compare these two. Okay, and this comparison is that whatever is here will be equal to this. So it means A straight away is equal to 7. We're told that y is in meter. Y is in meter. And A is the amplitude which is along y. So 7 meter. So that's the answer for I. I. Frequency. Okay. When we compare omega in the general progressive wave equation is equal to 40 pi. Because if you pick omega t, 40 pi t, the t will cancel out. So omega is equal to this. So omega is equal to 40 pi. And we know omega to be 2 pi f. So 2 pi f is equal to 40 pi. 2 cancels 40, 20 pi. So f is equal to 20 hertz. Okay, so finish up from I to VI. Finish from I to VI for me. Start with. And make me proud. Right, so I had paused recording and nobody told me.
Two for two meters. Sir, please can you hear me?
Yeah, I'm listening.
Sir, please, I had 240 centimeters.
Wavelength. Wavelength.
Yes, please.
You had 240.
Yes, sir.
I'm gonna look at it again. Oh.
Mr. D, I also had 240.
Look at it again.
They had 16.
The answer is 16. The answer is 16. Who else had 16? Apart from Adwa. Samuela, you had 16 too.
Yes, please.
Who else? Othniel, Calvin, Festus. Okay, so let's understand why it is 16, but not 240. You see, your issue is that when you write y is equal to a sine omega t minus kx, and you put in a sine 2 pi f t minus 2 pi over lambda x. Maybe you factorize a sine 2 pi f t minus x over lambda. You cannot directly compare it this way, that you are giving y is equal to 5 sine 30 pi t minus x over 240. You can't compare this directly to this and then say that x lambda is 240. The reason why you can't do this is this. Don't forget, whatever is here is not the same as what is here. Before you can do that, this is what you must do. 5 sine, let me leave 2 pi here. If you leave 2 pi here, then you must have 15t. Okay, then you think of what to multiply by 2 pi to give you x over 240, or to give you whatever is here. Okay, so the best way out is that, let me rather have it like this. Instead of factorizing 2 pi out, let me rather leave it like this. And in the equation given to me, I push the 30 pi, which is outside the brackets, into the equation so that there's nothing here. Then I can compare very well. Amma, are you following?
Yes, sir.
So the best way out is that 5 sine, let me push the 30 pi, which is outside the bracket, into the equation before I make the comparison. So I have 30 pi t minus 3, or 30 pi x on 240. Then I have 5 sine 30 pi t minus 3 pi x on 24. Then I can compare this with a sine omega t minus kx. Because there's nothing in front, I can now compare. So it means that k is equal to 3 pi on 24. K is equal to 2 pi over lambda. So 3 pi on 24, pi, and you make lambda the subject. Lambda would be equal to 2 by 24 over 3. 3 goes into this 8. 2 times 8, 16. And I'm told lambda is x is in centimeter. That's the way out. Charlotte, are you okay?
Yes, please.
So you must look at what you are given and what to do so that they will be alike for you to make the comparison. All right. Frequency. Yes, those of you who have solved it, what did you make for frequency? Frequency. Adwa, Calvin, Festus, Doku, F. What have you made for F?
I had
Charlotte,
15 heads.
15. Frequency, yes. Frequency is 15. This is because this time we have 2 pi F equated to 30 pi. So 2 goes into 30, 15. Velocity of the wave. Velocity of the wave. Adwa,
Sir, 240
240 Ghana cedi.
meter per second.
Better. Hey, did you say meter per second?
Centimeter.
So 240 centimeter per second. V is equal to F lambda. F is 15. Lambda is 16 centimeter. Okay. Or, I think that's it. That's it. Then, the displacement when t is equal to 0 and x is equal to 2 centimeter. Yes, who managed to finish this? This particular question. Who managed to finish the question? The last question. Yes, Charlotte.
Please, I have 0.4155.
0.
4155.
Attempt not bad, but answer not correct. Okay, who else? I saw another hand up.
Oh,
Pardon? All right, let's do that quickly. Y is equal to 5 sine 30 pi t minus x on 240. And we are asked to find the displacement y when t is 0 and x is there. So 5 sine 30 pi t is 0, x is 2 on 240. So we have 5 sine of 30 minus 1 on 120. So 5 sine of minus 30 pi on 120. This is minus 5 sine of 30 over 120 is 3 on pi over 12. That's when the zeros cancel out. So minus 5 sine pi on 4. So any value in front of sine is an angle in radian. That is why this is even expressed as pi. Okay. So let's change pi on 4, which is an angle in radian to degree. So we have minus 5 sine of, what is pi on 4 in degree? What is pi on 4 in degree?
45 degrees.
So 45. So we have changed the angle in radian to degree. Sine 45 is root 2 on 2. Root 2 on 2. So minus 5 times root of 2 on 2 is equal to negative 2.5 times root 2. What is 2.5 times root 2? That is minus 3.535. Minus 3.535 centimeter. Is that not it?
Yes.
So if t is 0, x is 2, the displacement will be equal to negative. Please, I changed this because you see, we had sine minus 3 pi on 12. Now, if you have minus of an angle, it's the same as, so if I have sine of negative theta, it is equal to negative sine theta in your EMAT. So I'm using the EMAT principle to change this. That is why I quickly change sine minus 3 pi or 1 on 4 to minus sine 1 on 4 pi. Any question? No question. All right. So this is where we end today's show. I'll send you sample questions to engage or try your strength with during the weekend. Please, bye-bye and take care of yourselves. Have a very wonderful weekend. Since this is our last meeting. See you. Assignments. When assignments come, please do well and submit. Charlotte. I'm not mentioning your name. Okay, bye-bye. Samuel, are you too? Annalyn, Lois, nah. Okay, that's for nah. She does well. Dennis, and the rest of you, bye-bye.
Bye.